Well, today we're going to tackle one of those pesky topics that just keeps showing up like a bad penny. So our review topic tonight is properties of exponents, and we have two big goals. Our number one, we want to be able to simplify an expression completely, and number two, we want to be able to determine which two expressions are equivalent. Now, this is really motivated by what we're seeing on multiple choice questions. And what I want to review tonight a little bit is, and I want you to write the word calculator here in parentheses, is we're going to use your calculator tonight to cheat a little bit and to try to determine which two expressions are equivalent. In other words, they're equal to each other, they just appear to be different at first glance on the surface. Okay, real fast here. Our first property is named the product property, and it's going to look like this. If we take one term, x to the m, and we multiply it by the second term, x to the n, we actually add the two exponents, making it x raised to the m plus n power. An example of that would be like x to the 5th multiplied by x to the 8th would equal x to the 13th. Number two is called the quotient property. And you could probably anticipate some division coming down the pipe here. So if I had x raised to the m and I divided that by another expression, x raised to the n, I would actually subtract the two exponents, and it would be x raised to the m minus n. And an example of that might look like x to the 5th divided by x to the 8th, which would equal x to the negative 3, and we could just rewrite that as 1 divided by x cubed, making the exponent positive. Our third big property is called the power property, and this says if you take an expression like x to the m and then you raise that to the nth power, we're going to multiply the two exponents, making it x raised to the m times n. So definitely compare property number 3 with the first one we wrote down and notice the difference. So if I took x to the 5th and I raised that to the 8th, what I'm really saying is I want to take x to the 5th and I want to repeat it 8 times. And we're not going to rewrite it 8 times, but we could, and you'd end up getting x to the 40th by the time you repeated it 8 times and added the 5 8 times. Of course, the shortcut is just to multiply the two. Now, another one we want to take a look at is, we'll call it fractional exponents. And just what do I do when I have an expression like x raised to a fractional power? So if I have x raised to the m divided by n, we would rewrite this as the nth root of x raised to the m power. And in a weird way, I like to call this the Groundhog Rule. Your denominator is like a groundhog that's going to dig a hole underground, burrow under the x, and then pop up on the other side. So we're going to go put these properties in action here. So we've basically filled our toolbox, so to speak, with the 4 properties that we just put in our notebook. And we want to be able to reach into that toolbox, pull out the appropriate property and apply it to this expression here and get it simplified as much as we can. Now, the one thing I like to do is, as I recall in my order of operations, is I want to simplify anything and everything inside of these parentheses first. So almost ignore this negative 1/5 power and pretend it doesn't even exist. What I'm going to use is I'm going to use the quotient property right here. So inside the parentheses, I really have m and raised to the 3 minus 1/4 power. And then, of course, the whole thing's raised to the negative 1/5, but I'm not really paying attention to that. And as I subtract the two, I'm creating common denominators, and the 3 really is 12/4. But you don't even need to do this by hand. You could certainly do it on the calculator. 12/4 minus 1/4 is 11/4. Now I'm going to raise that to the negative 1/5. I'm going to reach into my toolbox and I'm going to pull out what we call the power property. And what I want to do is I want to multiply these two powers together. And when I do that, I definitely get a negative number. And 11 times 1 is 11. And 4 times 5 gives me 20. And now I want to rewrite this so that the exponent becomes positive. So it would be 1 over m raised to the 11/20. And then I'm going to reach into my toolbox one more time, and I'm going to rewrite this as a root. This would be the 20th root, okay, of m raised to the 11th. Try saying that out loud. 1 divided by the 20th root of m raised to the 11th. And I think being able to communicate with a partner tomorrow in class is going to be just as valuable as anything else. Our second big goal tonight is being able to determine which of these 4 expressions is equivalent to this expression. And I want you to really highlight the word equivalent in your notebook. And basically we're saying equivalent is which of these expressions would generate the same answer as this expression for any random number that you substitute for m. And we're going to use our calculator tonight as a backup plan. It's always nice to have options and more tricks up your sleeve, and that's what we're going to try to give you tonight and equip you with more options. So grab your calculator, and we're going to talk about how to proceed on our calculator. And just to clarify that you could read this, this is supposed to say m to the 5th power. This is going to be m to the 7 halves, or this is a 7 over a 2, and this is a negative 1/3 if you're having trouble reading it. But my first step, and this is kind of the funny step that seems confusing, but you're just going to pick any random number you want and store it on your calculator for x and hit enter, okay? And so I want to stress this number right here, there's nothing strategic about it. It's just any random number. And I would challenge you to try picking a different number than what I've picked to prove that it still works at the end of the day. Okay, now what do we do with that? What I'm going to do is I'm going to substitute the 4.25 into the original expression, and it should look like this. So here's what my screen looked like. Basically, I'm just replacing these m's up here with x's on my calculator screen, and I just used the alpha F1 to do a lot of different fractions. And there was actually, on my screen, there was actually parentheses here originally. I don't know where they went. They disappeared after I hit enter. But the key is I get this number right here. And there's nothing super special about that number except for the fact that I'm now going to plug in all of the choices on this multiple choice question to see which one generates the same answer. That's all we're doing, is we're looking for a match. We're looking for a matching answer, and once we find that match, we know we've got the winner. So let's go ahead and let's type in choice number 1 and see if we get a matching decimal value. So here is choice number 1 from the question. I just, instead of, I replaced this m with an x, and I typed it in, and I got negative 2.06. And you notice this number does not match this number. So what I'm going to do is I'm going to cross off this choice. I know it can't work. And then you'll notice I've also typed in choice number 2, and negative x squared is negative 180625. Again, that does not match the 0.485 number, so I'm going to cross this bear off as well. We've eliminated those 2 choices. So now I'm going to grab my calculator and I'm going to try to type in 1 divided by m squared. And here's choice number 3. When I typed in 1 divided by m squared, I got 0.55, yada yada. Again, it doesn't match this 0.485 number, so we'll cross him off. And then last but not least, I typed in choice number 4 using my alpha F1 and my radical sign, and I got 0.485. This number matches this number perfectly, so this is my winner. In other words, this expression is equivalent to the original, which is what we would have gotten if we simplified it by hand as we had in the previous example, but it's just nice to have options, and it's nice to be able to use the calculator. How did we do it? Remember, just pick any random number you want and go from there.